using Maclaurin theorem. Using Maclaurin theorem, show that for 0 less than theta less than 1, log of 1 plus x is equal to x minus x square by 2 plus x cube by 3 into 1 plus theta x whole cube. 1 plus theta x whole cube. Next one, deduce that log of 1 plus x is less than x minus x square by 2 plus x cube by 3 for x greater than 0. Solution. First we have to write Maclaurin's theorem. Okay, Maclaurin's theorem with the only theta x is there. That means Lagrange's form of remainder. First write the formula. Maclaurin theorem. Maclaurin theorem with Lagrange's form of remainder. Sorry. With Lagrange's form of remainder is what is the function f of x equal to f of 0, and see what is this one. This one is up to cubic, up to third degree. Okay, so let us write Lagrange's form of remainder up to third degree. Up to third degree is, I will write, okay, let me write first overall formula, then let us truncate it to up to third degree. X into f dash 0 plus x square by factorial 2 into f double dash 0 and so on. And lastly, what is this one? X to the power of n by n factorial fn theta x. Now, consider Maclaurin theorem. Since the required is up to cube, consider Maclaurin theorem with Lagrange's form of remainder. Lagrange's form of remainder up to third degree. Then what we have, f of x equal to f of 0 plus x into f dash 0 plus x square by factorial 2 f double dash 0, and this term with Lagrange's form of remainder x cube by factorial 3 f triple dash not 0 theta x. Okay, this is Maclaurin's theorem with Lagrange's form of remainder up to third degree. Now one by one let us calculate. F of x equal to log of 1 plus x. That implies f of 0 equal to log 1 0. Next one, f dash x equal to 1 by 1 plus x. So f dash 0 value 1. Next one, f double dash x value is minus 1 by 1 plus x whole square. So f double dash 0 value is negative 1. And f triple dash x is 2 by 1 plus x whole cube. That implies f triple dash not 0. What is the required? Theta x. So write theta x. F triple dash theta x equal to 2 by 1 plus theta x whole cube. Substitute all these values in 1. Therefore, 1 implies left side is what? F of x, that is log 1 plus x. F of 0 value 0 plus x into f dash 0 value 1 plus x square by 2. What is f double dash 0? Negative 1. And plus x cube by 6. And what is this? F triple derivative 2 by 1 plus theta x whole cube. This implies log 1 plus x equal to x minus x square by 2, and this is plus x cube by 3 into 1 plus theta x whole cube. This is our first derivation. Take this as equation 2. Take this as equation 2. Now what I have to prove? This inequality. What is this inequality? Log of 1 plus x is less than this part, is less than x minus x square by 2 plus x cube by 3. To get that, see, we have in Taylor's theorem, what is this theta? Theta belongs to what? Open 0, 1, right? Okay, theta is positive. Theta belongs to what? 0, 1. This implies theta is greater than 0. And given x is also greater than 0. And given x is also greater than 0. This implies, now let me get this term. Theta x is greater than 0. Theta x is greater than 0. Next step is, what is that? 1 plus theta x. 1 plus theta x. 1 plus theta x, adding 1 on both sides. Adding 1 on both sides. 1 plus theta x is greater than 1, right? Next one is whole cube is there. So 1 plus theta x whole cube is greater than 1 cube. That means 1. Okay, cubing on both sides. Next one, what is this? What is this? Multiplied by 3 on both sides. 1 plus theta x whole cube. 1 plus theta x whole cube greater than 3. Greater than 3. Right? Next one, what is this? Inverse, reverse it. 1 by, let us take. This implies 1 by 3 into 1 plus theta x whole cube is, what is this? Less than, is less than 1 by 3. Is less than 1 by 3. Right? Now, what is this one? This term is multiplied by what? I'm getting this entire term here. I'm getting this right hand side expression from theta x greater than 0. Next one is what? X cube is there. So let us multiply it by x cube. X cube by 3 into 1 plus theta x whole cube is less than what? X cube by 3. On multiplying on both sides by x cube, since x is positive, x cube is also positive, there is no change in the inequality. Okay, since it is positive, there is no change in the inequality. After x cube by 3, what is this term? This is plus minus x square by 2, right? Subtracting minus x square by 2 on both sides. Minus x square by 2 plus x cube by 3 into 1 plus theta x whole cube is less than minus x square by 2 plus x cube by 3. Plus x cube by 3. That means adding minus x square by 2 on both sides. Right? Next one is what? X. Let us add x throughout this inequality. This is x cube by 3 into 1 plus theta x whole cube is less than x minus x square by 2 plus x cube by 3. Okay. Now what is this expression from 2? From 2 we have, from equation 2, what we have, we get the left side expression is what? Log of 1 plus x expansion is less than what? X minus x square by 2 plus x cube by 3. This is the deduction of the given inequality. Okay, a simple logic once again. First, since observe the problem, since it is x cube by theta x is here, that means we have to consider Maclaurin's theorem, nothing but about point x equal to 0 up to third degree. So we have written this up to third degree, we have written this, and we are calculating the derivatives and the function values, and substituted in equation 1, I'm getting the series expansion of log of 1 plus x with Lagrange's form of remainder up to third degree. First point is over. Coming to derive the inequality, log of 1 plus x is less than something. I have this theta is belongs to 0, 1. So theta is positive, greater than 0, and x is positive. Let us get this entire expression from this theta into x equal to, actually x greater than 0. X greater than 0. Next multiplied by theta. Next plus 1 plus whole, next whole cube multiplied by 3. Then successive expressions, right? I'm getting this expression. Now one more problem based on same logic, using Taylor's theorem. Using Taylor's theorem, show that x minus x cube by 6 is less than sine x is less than x minus x square by 6 plus x to the power of 5 by 120 for x greater than 0. For x greater than 0. Okay, just I'm giving hint for this problem. The hint is you do assignment, this one, practice it. Now, first one, what is the function? F of x equal to sine x. Now here we have to prove how many inequalities? Two inequalities. We have to prove two inequalities. One is this and another one is this. Another one is x minus x cube by sine x minus x cube by 6 less than sine x, one inequality. Another one is sine x less than this x minus x square by 6, x cube. This is x cube by 6 plus x power 5 by 120. So first, to get this inequality, okay, to get or to prove, or this is to prove x minus x cube by 6 less than sine x, consider, see what is this one, is it is up to third cube, up to cube. So consider Taylor's theorem. Actually, Maclaurin's theorem, it should be given. Taylor's theorem of sine x about the point x equal to, point is not given means you must consider about x equal to 0. Taylor's theorem for sine of sine x about x equal to 0 with Lagrange's form of remainder. With Lagrange's form of remainder up to what? Up to third degree. Up to third degree. Okay, that is what f of x equal to f of 0 plus x into f dash 0 plus x square by factorial to f double dash 0 plus x cube by factorial 3 f triple dash, what is this? Theta x. Don't forget, don't put 0, theta x. Now, what is f of x? Substitute the required values. So first one, f of 0, sine 0. Next, f dash x, cosine x. F dash 0, this value 1. And f double dash x, negative sine x. This is f double dash 0 is 0. And next one, triple derivative. F triple derivative x equal to a negative cosine x. This is f triple derivative not 0. What is the value? Theta x. So this is minus cosine theta x. Minus cosine theta x. Okay. Then x cube only. Right. Therefore, 1 implies this is sine x equal to f of 0, 0. X into f dash 0, 1. Plus x square by factorial to f double dash 0, 0. X cube by 3 factorial f triple dash theta x, negative cosine theta x, negative cosine theta x. Therefore, what is sine x expansion? X minus x cube by 6 into cosine theta x. This is expression 2. Expression 2. Okay. Now, as usual, to derive the inequality, what I told, since x greater than 0 and theta greater than 0, both are greater than 0, what we have? Theta x greater than 0, theta x, right? Theta x greater than 0. The next term is what? Cosine. So assign cosine on both sides. Cosine theta x is greater than cosine 0. So cosine theta x is greater than 1. Okay. Next one is what? This cosine theta x multiplied by what? Minus. So minus x cube into cosine theta x. Shall I take 6 also? It is greater than becomes what? Since multiplied by minus, negative with multiplied by what? Minus x cube by 6.
Sir, cosine theta x is greater than cos 0, sir.
Yeah, theta x greater than 0. Taking cosine on both sides.
It will
Yes, sir.
change, sir.
Decreasing function.
Cos 0 is 1, sir. Cos cannot be greater than 1.
Function.
Decreasing function.
It will change, sir.
Right. Flow lo వెళ్ళిపోతున్నాను. Wait. Then you
Less
take
than or equal to 1, sir.
Yeah. Range of cosine is less than or equal to 1. Use that one. Theta greater than 0, and we have cos theta x is less than or equal to 1, right? Range of cos the -1 to +1, and cos theta x less than or equal to 1, this implies, and multiplied by this x cube by 6 cosine theta x is greater than or equal to minus x cube by 6, right?
It won't be equal, no, sir.
Where
Neither of them are 0. Theta is not 0, x is not 0. So it won't be equal to 1. Only less than 1.
here using this, so you write like this. Better you
Sir,
write this step
X
here.
less than 1 only.
Wait. I had to. You must written here. So we have cos theta x less than or equal to 1 generally. Next one, since x greater than 0 and theta greater than 0, x greater than 0, theta greater than 0, we have cosine theta x is less than 1. Cosine theta x is less than 1. Now multiplying on both sides by negative x cube by 6 cosine theta x, it is greater than minus x cube by 6. I think it is clear now, right? First condition, this is range of cosine x, maximum value of cosine theta x. But since both are not equal to 0, greater than 0, this cosine theta x is less than 1. Next one is what? Adding x on both sides. Adding x on both sides, x minus x cube by 6. And what is this value from equation 2? Sine x. Okay, using 2, we get this sine x is greater than x minus x cube by 6. That is nothing but the first inequality, left side inequality is this one, equation 3. Similarly, now same logic to prove what is the another inequality. Sine x less than x minus x cube by 6 plus x to the power of 5 by what is this, 120. Consider Taylor's theorem. Consider Taylor's theorem about x equal to 0 with Lagrange's form of remainder. With Lagrange's form of remainder up to what is the degree? 5th degree. Up to 5th degree. Up to 5th degree. So what is the expansion now? F of x equal to f of 0 plus x into f dash 0 plus x square by factorial 2 into f double dash 0 f double dash 0 plus x cube by factorial 3 f triple dash 0 x power 4 by factorial 4 f fourth derivative 0 and fifth one is what? 5 factorial f fifth derivative theta x. Fifth derivative theta x. Take this as equation 4 and calculate the required derivatives. F of x equal to sine x. So f of 0, 0. I think you can do this one, right? Okay. Remaining is assignment. And get this expression finally. What is this expression? Finally, you will get this one, x minus x cube by 6 plus x to the power of 5 by 120. Take this as equation number 5. Equation number 5. Lastly, combining 3 and 5. Combining 3 and 5, we get, combining 3 and 5, we get x minus x cube by 6 less than, this is the first inequality, and sin x is less than x minus x cube by 6 plus x to the power of 5 by 120. Okay, this is one model. Now, the problems using successive differentiation. Problems using successive differentiation. See, another one. expand e power a sine inverse x in ascending powers of x. In ascending powers of x. This is the question. Solution. Point is not given, so, and it is a series expansion completely. No need of any remainder term. Since point is not given, it is Maclaurin series expansion. Maclaurin series of f of x is f of x equal to f of 0 plus x into f dash 0 plus x square into f double dash 0 and so on and so on. Equation 1. Now what is the function? Let f of x equal to e power a sine inverse x. A sine inverse x. Okay, you can find the derivatives also successively. Find f of 0, next find f dash x, then f dash 0, f double dash x, then f double dash 0 and so on. Okay, but the thing is, if you want more number of values, more number of terms in the series expansion, see the logic. First, or let me, instead of y equal to f of x, what is this? General notation is y is a function of x, so y equal to f of x. Let me take, instead of f of x, as y, for our convenient only, to get the, to write the derivative terms, y, y1, y2, like that. Okay, from this is y of x. What is y dash x? Okay, sorry. First, after this, write this y of 0. Y of 0 is nothing but what? F of 0, this value 1. Now, coming to y dash, first one, y dash, e power f of x derivative, e power f of x into f dash x, a sine inverse x derivative, 1 by 1 minus x square, right? And next one, y dash 0. This is y dash, means y dash x actually. Y dash 0 is nothing but, y is nothing but f dash 0. What is f dash 0? This is 1, a value becomes a. Okay, next one, coming to get the double derivative, take this 1 minus x square left side, 1 minus x square into y dash equal to a into e power a sine inverse x, right? Now this is 1 minus x square into y dash. What is e power a sine inverse x? Y, since y equal to e power a sine inverse x, right? This is the alteration from y dash. Now again differentiate, then this is uv method, this is u and this is v, product rule. So first one, let me keep 1 minus x square constant and y dash derivative y double dash. Next, plus y dash as it is, and the root of 1 minus x square derivative 1 by 2 root of 1 minus x square and 1 minus x square derivative equal to, what is this? A y1 or y dash. See, let me change this. Instead of y dash, let me write y1. To get in successive differentiation, I need y1. Here y dash is nothing but y1 notation. Okay, now here also one can write y. Okay, let me write first. What is this? Y dash. Next step, this 2 gets cancelled. Taking LCM on both sides, this is 1 minus x square y double dash minus x into y dash, right? Equal to a into root of 1 minus x square y dash. Is it correct? A into root of 1 minus x square y dash, right? Now see, from this expression, 1 over root of 1 minus x square into y dash is what? Ay. So substitute here ay. Okay, the next step is, now this is 1 minus x square y double dash minus x y dash equal to, this is a into, what is this value? Ay, in bracket, since 1 minus x square into y dash equal to ay. Now the expression, there is an, I'm changing the notation, that's it. 1 minus x square, y double dash is y2, and this y dash is nothing but y1 equal to a square y. Here, y dash is notation y1, y double dash notation y2. Okay, y2 stands for double derivative. Okay, now after getting this, okay, take this as star, equation star. Now put x equal to 0. Why? Because I need what? F double dash 0. Put x equal to 0. Then this is y2 of 0, this value 0, and minus 0. This is a square into y of 0. This implies y2 of 0 is nothing but a square into, what is y of 0? Nothing but f of 0. What is its value? Starting y of 0 value 1. So this value is a square into 1. This is a square. Now from this now onwards, see how the derivatives are calculated. Let us use star equation. 1 minus x square y2. To get third derivative, fourth derivative, fifth derivative, always remember you must calculate up to second derivative. You must calculate up to second derivative. Get one equation in terms of second derivative. That means exactly this. Okay. Then taking nth derivative on both sides. Taking nth derivative. Directly taking nth derivative on both sides. On both sides. 1 minus x square y2. This is the notation. N times differentiation for this function. xy1 n times differentiation. A square is the constant for y, n times differentiation. N times differentiation. And now the rule is Leibniz rule. Leibniz rule for successive differentiation. For successive differentiation. Successive differentiation means first derivative, second derivative, third derivative successively. We are finding derivatives, Leibniz rule for successive differentiation. There are two functions. One is u and another is v. Both are functions of x and its nth derivative. Product of two functions u, v, and their nth derivative is, first one, you take u as it is, for v nth derivative, plus. Okay, once again, first write u as it is for v nth derivative. Next one, nc1, actually this is nc0, that's value is 1. nc1, take for u first derivative, and for v decrease one derivative n minus 1. Decrease one derivative n minus 1, plus next term is nc2, for u one more derivative, increase the derivative of u and decrease the derivatives of v, plus, and so on. What is the last one becomes obviously ncn. For u you will get nth derivative, and for v it's a constant. That means write v as it is. This is the formula of Leibniz rule. And you know what is nc1? N. nc2, I'm giving direct n into n minus 1 by factorial 2. nc3 value n into n minus 1, n minus 2 by factorial 3, and so on, like this. Okay, so let me apply this successive formula for this. Now here this is u and this is v. In this one this is u and this is v. Okay, and there is no only single function, so as it is. So once again I'm writing this. What is this? 1 minus, okay, 1 minus x square y2 for this nth derivative, and minus xy1 for this nth derivative equal to a square y for this nth derivative. Now what is this? This is u and this is v, and here this is u and this is v. So first one, okay, let me write in the next page. this implies first one u as it is, 1 minus x square as it is. Next for y2 means y double derivative. For y double derivative, nth derivative becomes what? N plus 2th derivative. N plus 2th derivative plus nc1. Now for u, the first derivative, what is 1 minus x square derivative? Minus 2x, and decrease one derivative for yn plus 2. That becomes yn plus 1. Next plus nc2, and increase one more derivative. What is that? Minus 2, and decrease one derivative in yn plus 1. Next for this one, what is the next two derivative? 0. So stop here. This is the first bracket expansion using Leibniz formula. Next minus, coming to second one, u value x. For y1, nth derivative is n plus 1 plus nc1 into. For u, derivative is 1, and for yn plus 1, decrease one derivative yn, and next one derivative 0. So stop here. Next one, a square. For y, nth derivative is yn. For y, nth derivative is yn. Now in Maclaurin series, we are calculating all the derivatives at what point? 0 only. So you put directly x equal to 0. Put x equal to 0. To simplify, that means to get the derivatives at a 0 point. Put x equal to 0. Then what I'm getting, this is first term yn plus 2 0. This is actually x. Okay, right? Now n minus. Anyway, x equal to 0 means what? 0. So second term 0. And third term minus 2. nc2 value is what? N into n minus 1 by factorial 2. yn 0. This is first bracket. And second one minus this x value 0. So this is 0 plus nc1 n value, and this is yn at 0. Yn at 0 equal to a square yn at 0. A square yn at 0. So this 2 gets cancelled. This implies yn plus 2 to derivative 0, and what is this becomes? Minus minus n square yn 0, and minus into minus plus n yn 0, and this is minus n yn 0 equal to a square yn 0. These two gets cancelled, and n plus 2 the derivative at 0 is, take this term that side and yn 0 common. So this becomes a square plus n square yn 0. This is expression 1. This is valid from for what? Already up to y2 we have calculated. y2 0 is over. So this is from n greater than or equal to 1. That means we are getting derivatives y3 and so on. Okay. Now for n equal to 1. N equal to 1 means y3 0. Y3 0 is nothing but what? N equal to 1 means a square plus 1 square. N equal to 1, y1 0. What is y1 0? What is y1 0? Where is it? y1 0. Yes, y dash 0 is a. Y dash 0 is a. So this is a into a square plus 1 square. Okay, in bracket, since y1 0 equal to y dash 0 equal to a. First one is over. When n equal to 2, y4 0 equal to a square plus 2 square into y2 0. y2 0 means y double dash 0. Where it is? Yeah, y2 0 is what? A square. y2 0 is a square. So a square into a square plus 2 square. In bracket, since y2 0 equal to a square. Next one, n equal to 3, y5 0, a square plus 3 square. What is this? y3 0. In the formula, if I put 3, n equal to 3, and y3 0, I add this. What is this? Let me write first y3 0, a into a square plus 1 square. Next, a square plus 3 square. And let me write only one more. N equal to 4, y6 0 equal to a square plus 4 square into y4 0. You will get y4 means this one. So let me write first this. a square into a square plus 2 square into a square plus 4 square, and so on. Substitute all these derivatives in equation 1. Remember, y of x is nothing but f of x. According to that, derivatives also. So what is f of x equal to? F of x equal to, let me write what is f of x, e power directly. Why should I write one more step? This is e to the power of a sine inverse x equal to, first one, f of 0, 1, plus x into f dash 0. What is f dash 0? A. X into f dash 0, a. X square by factorial to f double dash 0, a square, plus x cube by 3 factorial f triple dash. It is here. What is f triple dash? This one. A into a square plus 1 square, plus x power 4 by 4 factorial. Fourth derivative. What is that fourth derivative? A square plus 2 square. A square into a square plus 2 square. And fifth one, 5 factorial. What is this? A into a square plus 1 square, a square plus 3 square. And lastly, 6 by 6 factorial. A square into a square plus 2 square, a square plus 4 square, and so on. Okay, whenever if you want to compute higher degrees, then use successive differentiation formula. This is one method. E power a sine inverse x. Now take one more problem. Expand directly. Let me take y equal to, first one, f of x equal to sine of m sine inverse x. Second one, f of x equal to cos of m cos inverse x. Third one, f of x equal to sine inverse x whole square. Sine inverse x whole square. Again assignments. Enough. That's enough. Now tell one problem we will do. Anyone? Among three? 1, 2, 3.
Second one, sir, cos of m cos inverse x.
మిగతా చేసుకుంటారా?
Yes, sir.
Okay. Second one. F of x equal to cos of m cos inverse x. I will tell first one because derivatives are very easy. For cosine and negative terms will be there, right? You try sine of m sine inverse x. Okay, this is equal to y of x. I'm taking directly Maclaurin series. Y of x equal to Maclaurin series y of x equal to y of 0 plus x into y dash 0 x square by factorial to y double dash 0 and so on. Equation 1. Now first one, y of x equal to sine of m sine inverse x. This implies y of 0 is 0. Next, y dash, nothing but y1 I am taking directly. Okay, y1 or y dash equal to cos of m sine inverse x. ఇక్కడ కూడా cos వచ్చింది కదా, doesn't matter. Okay, cos of m sine inverse x and m sine inverse x derivative. Yes. Okay, and what is y dash 0 now? This m will be there, and sine inverse 0 0 cos 0 1, so this value is m. Next one, take this 1 minus x square left side, so root of 1 minus x square into y1 equal to m into cos of m sine inverse x, right? If any corrections, please give. 1 minus x square y1 m into cos of, right? Next, now differentiate. This is 1 minus x square constant for y1 derivative y2. Now y1 constant for root, the derivative is this, equal to, now coming to this, minus m sine inverse x, and this is m by root over 1 minus x square, this one derivative, m sine inverse x derivative, next one, this equal to 1 minus x square y2 minus x y1 by root over 1 minus x square equal to, this is into, okay, minus m square. What is sine m sine inverse x? Y. Okay, my by root of 1 minus x square. Okay, this value is y. Sine of m sine inverse x value, the function y. Now taking LCM 1 minus x square on both sides, this is 1 minus x square y2, right? Okay, minus x y1 equal to minus m square y, right? Now put x equal to 0 here. This implies y2 of 0 equal minus 0 equal to minus m square y of 0. Minus m square, take this as star equation. And what is y of 0? Y of 0, 0. So y2 of 0 value 0. Since y of 0 equal to 0. Okay, this is over. Now let us deal with star equation. What is star equation? 1 minus x square y2 minus x y1 then equal to minus m square y. Taking n times differentiation, we have, this is 1 minus x square y2 n times x y1 n times minus m square y n times. Now again Leibniz rule. This is u and this is v. First one, u as it is 1 minus x square for y2 n times differentiation n plus 2th derivative plus nc1 for 1 minus x square derivative minus 2x and decrease one derivative here y n plus 1. Next, plus nc2 minus 2x derivative is minus 2 and decrease one more derivative. This is first bracket. Minus, same logic for the second one, x y1. X as it is for y1 n derivative n plus 1 plus nc1 x derivative 1 and decrease one derivative, and next one derivative 0, finished, equal to minus m square for y nth derivative is yn. Okay, now since we are calculating all the derivatives at x equal to 0, put x equal to 0. Then what is this becomes? This is yn plus 2 0 and this is minus 2 will be there, nc1 n x will be there, sorry, this value 0, x value 0 now, so this value is 0, completely 0, minus 2 into nc2 n into n minus 1 by 2 yn 0. This is first bracket. And the second one, minus this x is there 0 plus nc1 n yn equal to minus m square yn 0. This is yn 0. So this equal to yn plus 2 0 equal to, or minus this 2 to cancel, minus n square yn 0 and minus into minus plus n yn 0, and here minus n yn 0 equal to minus m square yn 0. These two cancel and take this term to right side. So yn plus 2 0 equal to n square minus m square yn 0. This is 1. This is valid from n greater than or equal to 1, third derivative onwards. So put n equal to 1 here. Now for n equal to 1, this is y3 0 equal to 1 square minus m square y1 0. What is y1 0? y1 0 means this part, m. So m into 1 minus m square or 1 square minus m square. For n equal to 2, y4 0 equal to 2 square minus m square into y2 0. I think y2 0 is 0, right? y2 0 is 0. So this part 0. For n equal to 3, y5 0 equal to 3 square minus m square y3 0. That means first y3 0, let me write. So m into 1 square minus m square and 3 square minus m square, and so on and so on. Therefore 1 implies f of x equal to, f of x means what? Sine of m sine inverse x is equal to f of 0 plus x into f dash 0. What is the value of f dash 0? I think m. Next, x square by factorial 2 f double dash 0 0, x cube by factorial 3, third derivative is m into 1 square minus m square, and fourth derivative 0. Fifth derivative is m into 1 square minus m square, 3 square minus m square, and so on. Sixth derivative 0, and seventh derivative is 5 square minus m square up to. So finally sine of m sine inverse x is equal to mx plus m into 1 square minus m square x cube by 3 factorial plus m into 1 square minus m square 3 square minus m square x to the power of 5 by 5 factorial, and so on. This is the expansion of sine of m sine inverse x. Okay. Now, any doubts? And solve the remaining problems. These are problems on Taylor series. Problems on Taylor series and Maclaurin series, Taylor's theorem and Maclaurin's theorem. Some more problems are there. I will write the notes and just post you. Those are very simple problems. Okay. No need to waste time. Any doubts?
Sir, in question, if it is not provided that till which power we have to do, sir?
Which power you have to do? For example, if it is a short question, take up to third degree. Okay.
Okay, sir.
If it is essay question, up to fifth degree, sixth degree, like that. If, for example, if you see this problem, second derivative 0, fourth derivative 0, na, in the series,
Yes,
there must be at least 3 non-vanishing terms. In a series, there must be at least 3 non-zero terms. You expand up to that. Okay.
Okay, sir. Thank you, sir.
Any more? Okay. I will stop here. Prepare up to Taylor's theorem, Taylor series. Mostly syllabus is up to Taylor series. Okay. Up to today.